Welcome to Meteorology 101. Visit our website at meteorology101.com. Generally, severe convective weather extends from the Continental Divide to the Appalachian Mountains, and Gulf of Mexico to Canada. The season that favors tornadic activity is March through June, and March through September for severe thunderstorms. Thunderstorms occur most frequently over the southeastern U.S. The favored season is during the warm summer months. A secondary area of thunderstorm activity occurs during the summer nights over the Great Plains. Frontal thunderstorms are mainly responsible for the activity over the rest of the country. Severe thunderstorms and tornadoes are diurnally prevalent during the late afternoon and evening due to max surface heating, and in the early morning during winter along the Gulf Coast due to radiational cooling aloft. These are times of maximum atmospheric instability. Thunderstorms are noise-making machines that create a variety of weather phenomena: lightning, strong winds, hail, turbulence, icing, and heavy rain. Weather associated with thunderstorms: strong surface winds, lightning, hail, heavy rain. Surface wind speeds, up to 49 knots, generally move small objects around, and reduce the visibility due to blowing dust and debris. Wind speeds, greater than 50 knots, can cause damage to structures, and smaller objects may become projectiles. Lightning usually stops refueling operations due to the explosive situations that exist on most flight lines. Personnel, who work outside, must limit their time because of the probability of being electrocuted. Hail less than 1 inch is a danger to personnel in exposed areas and will damage weak structures, i.e., windshields and vehicles. Hail greater than 1 inch could seriously injure personnel in exposed areas, and will do significant damage to exposed aircraft, vehicles, and facilities. Heavy rain is defined as greater than 2 inches of rainfall within 12 hours. Slow-moving or stationary convective cells produce heavy rain over the southeast U.S. during the summer months. The focus shifts to the Gulf Coast region in August to September. The area of heavy rainfall relocates to the west coast in the winter. Tornadoes appear as a funnel-shaped cloud pendant from the base of cumulonimbus cloud and/or a swirling cloud of dust and debris rising from the ground. Tornadoes usually appear in the right rear area of the CV. This is where the inflow is entering the storm updraft core. The wall cloud usually represents the area of the updraft. Tornadoes generally form on the periphery of the wall cloud. Tornado movement is governed primarily by the motion of the parent thunderstorm. Average movement is from southwest to northeast with an average speed of 30 miles per hour. Smaller scale motion can be in any direction as the tornado often moves in a circular pattern under the parent thunderstorm. Smaller scale speed is controlled by the tornado motion under the parent thunderstorm. Speeds from 0 to 70 miles per hour have been observed. What makes a tornado so destructive? Wind-shear. The Bernoulli Effect. Over-pressurization. The main reason for tornadoes being so destructive. Calm wind is often observed just before a tornado onset. In a matter of a few seconds, speeds could go from 0 to 200 miles per hour. Directional wind shear of 360 degrees occurs in a matter of seconds when a tornado moves across a structure. The Bernoulli Effect. The increasing winds over an object will create an area of lower pressure. Due to the pressure imbalance, this shift causes a roof to become detached on homes whose roofs aren't well attached. This can cause the walls to fall outward, giving the impression that the house exploded. Over-pressurization can cause a rapid decrease in pressure outside the house, which is common during a tornado passage. This effect would be multiplied if doors, windows, or garage doors were blown open on the upwind side. Mass and pressure would build up inside the house, again giving the impression of an explosion. Convective scale atmospheric dynamics. The four basic ingredients for thunderstorm formation: instability, moisture, lift, exhaust. Instability. Instability is defined as a condition of the atmosphere whereby a parcel of air, given an initial start vertically, then continues to move upward without any outside force. Moisture. Increased moisture in the low levels will modify the dew point, which will lower the convective condensation level, the lifted condensation level, and the level of free convection. As a saturated parcel is lifted and cooled, latent heat is released into the atmosphere. This process slows the cooling rate of a parcel as it ascends through our atmosphere. If this rate is less than the environmental lapse rate, the parcel will continue to rise after it reaches the LFC. Lift. Before a parcel can reach its level of free convection, it must have a force that initiates the upward vertical motion. This lift can be on a synoptic or mesoscale. Examples of synoptic scale lift are mid and upper level shortwave troughs, jet stream maxima, and warm air advection. As convergence occurs in the low levels of the atmosphere, there must be an exhaust for thunderstorms. Upper level divergence is required. Upper level divergence will not produce thunderstorms, but it will enhance the process. Lifted condensation level is the height at which a parcel will become saturated when lifted by a mechanical force. Clouds will begin to form when air becomes saturated and water vapor condenses. Convective condensation level is the height at which a parcel will become saturated when heated from below and rises adiabatically. Level of free convection is the height at which a lifted parcel of air becomes warmer, or less dense than the environment. These videos, although short, take hours to create. Please consider clicking the thumbs up and sharing this video.